The lowest common multiple. We know what are multiples, right? To recap, multiples, as discussed before, right, are numbers that said number can divide into without giving it a remainder. So, like, if you're looking for multiples of 3, 3 times 1, 3 times 2, 3 times 3, 3 times 4, all those are multiples, right? Whereas factors are the opposite, right? But anyways, so for multiples, let's go through a few examples. Before it, what is the lowest common multiple, right? The lowest common multiple is the lowest common multiple between two or more numbers, right? It's that simple. Let's do a few examples, right? Let's find the lowest common multiples for numbers 8 and 12, right? 8 and 12, right? I'm going to list a few auto multiples and then we'll see where the commonality is, right? So let's go. Right. These are the first 5 multiples of each number, right? Now, which numbers are common? (24) and 24 common. No other numbers are common. But if they were, right, let's say they were other common numbers, right? The lowest common multiple will be the one that's, lowest. So 24 in this case, right? And you can do this over and over again, right? When dealing with bigger numbers, right, we usually use the ladder method, right, which we previously learned, right? If you haven't learned about it, you can go to my previous videos and you can watch it again. So let's do one that involves the ladder method, right? We got to find we're gonna find the lowest common multiple we're gonna find the lowest common multiple of 22 and 48, right? Right. So this is the products of each number, right? So for the LCM, for the lowest common multiple, we're looking at each base, not those that are in common, but all of the bases, right? We're looking for the highest exponent of each, right? The highest exponent of each. So in this case, we have a 2, we have an 11, and we have a 3, right? What's the highest base? What's the highest exponent that has a base of 2? This is why it says 4. The highest exponent with base 11, 1, right? And the highest exponent with base 3 is y, right? And you simply plug this into a calculator or whatever, and your answer will be 528, right? Let's do another example. Right, we'll find the lowest common multiple of 10, 882, and 847, right? We're going to use the ladder method, right? Because the big numbers here and we don't know the multiples, right? Great. But 10. Right. So these are the prime factors for the following numbers, right? Lowest common multiple we're looking at all the bases, not those in common, but all of the bases, right? Go through it. We have 2 here, we have a 5 there, we have a 3 here, we have a 7 here, and we have an 11, right? What's the highest base of 2? 1. The highest base of 5? 1. The highest base of 3? 2. Highest base of 7? 2. Highest base of 11? 2. Right? Now you plug this into a calculator, and your answer will be 533,610. Right? That's your answer. Right? So, yeah. Remember that when you're finding your LCM, the lowest common multiple, the bases do not have to be common. Look at all the bases. When you're looking at your highest common factor, that's when the bases have to be common. You're looking at the lowest exponent. Right? I'll repeat that. Lowest common multiple, we're looking at all the bases and each base with the highest exponent. Right? HCF, the highest common factor, you're looking at the common bases and with the lowest exponent.